Welcome to the first part of Retool Fit for road bikes. It is important that you have already completed and understand the pose definitions in the previous module. Even better to just have a copy of the PDF open while you're taking this course. In addition to that course, it could also be helpful if you've already completed the Retool Eval Pre-Fit Assessment course before getting into this one, because we're going to be referencing a lot of that information as we move through these steps. Now we will cover the first half of the fitting process. Steps 1 through 8 set the XY plane, or the side view of the rider. These steps cover the cleats to the seat, then the reach to the handlebars. Step 1 is saddle selection. We start here because the right saddle provides the foundation for the entire fit. Measure the rider's current saddle width and review the assessment to know the rider's actual sit bone width. Determine if the rider's current saddle offers ideal support. If not, suggest a proper width saddle for the rider's sit bone measurement. Hip vertical travel is a good indicator of saddle support. Look for relative symmetry left to right, less than 15 millimeters of difference. The best saddle should help to reduce the amount of hip vertical movement, or at least not increase this value. Hip lateral travel, maximum knee extension, and knee forward of spindle are other data fields where you should look for relative symmetry. Notice the asymmetry in this rider's hip travel. This may be because she is only supported on one side of the saddle. Also possible is knee angles that are different because the rider is falling off the side of an unsupportive saddle. If the rider is not sitting squarely on an unsupportive saddle, she could also show significant asymmetry in knee forward of spindle. This rider is displaying asymmetries across many fields. So how do we know if it's the saddle or something else? Refer back to the pre-fit assessment to find the answers in the rider's structures and ranges of motion. Watch the rider pedal from the side. Notice if they are sitting evenly on the saddle or if they are pushed too far back or too far forward. Also look at the rider from behind. Is the rider centered or are they falling off to one side of the saddle? Review the assessment to remember their ischial tuberosity width. Measure the saddle width to see if it's properly sized for their sit bone measurement. Suggest the proper width saddle if the rider is not fully supported on their current saddle. Cleat placement is adjusted in two ways during this step. Set fore and aft by locating the first and fifth metatarsals, and observe above the foot to see if the middle of the pedal spindle falls in between. Next, set the cleat's rotation based on the rider's neutral foot position. Foot rotation mean is the average angle of the foot. A straight foot is usually between 8 and 11 degrees, depending on the size and shape of the rider's shoes. Before starting the fit, the fitter should have checked all of the rider's equipment, like footbeds, wedges, cleats, and the saddle. Here, the fitter needs to make sure the cleats do not need to be replaced and that they are starting in relatively the same position fore to aft. Watch the rider pedal from the front. Note the foot rotation. Have the rider unclip and hold their foot and knee at 90 degrees. Does the clipped-in rotation closely resemble the unclipped or natural foot rotation? Adjust their cleats as necessary to match that natural foot rotation. After making the adjustments to the cleats, have them clip back in and make sure that their foot is centered in the float with a little bit of movement available both to the outside and to the inside. Our next step is setting the rider's saddle height. Most often, the rider will be getting fit on their existing bike, so you will have started the fit with the position that they've been riding. If performing a fit on a new bike or on the move, and the rider does not know their saddle height, the heel back pedal method is an easy way to find a starting point. Before getting into the data, remember to reference the rider's hamstring range of motion. If they had limited range of motion, they may be limited in how much they can open up their knee angle through the bottom of the pedal stroke. The rider reaches to the bottom of the pedal stroke by extending the knee, pointing their toes, and opening their hip. Retool Vantage measures all three of these movements dynamically under a real effort by the rider. This data shows the fitter exactly what is happening at the key joints for setting the rider's saddle height. Observe this rider's data. Notice first that the knee extension is more closed than the average range. and the rider is driving their heels and closing the ankle angle less than the average range. Of these three lines, these two are the most telling, showing that the rider is riding with their saddle too low. Raise the rider's saddle and the data comes into range by opening the knee and ankle angles. If necessary, use the heel back pedal method to come up with a starting saddle height for your rider. Once you have a starting point, refer to your data and make the necessary adjustments to get the rider's knee angle within range. The goal of moving the rider's saddle fore and aft is to position the approximate center of the knee over the center of the pedal. So the first step in this process is to define pedal center by using the Find Pedal function in the software. Once Find Pedal is clicked, a dialog box opens with specific instructions. Follow these two steps and the software will find the center of the pedal spindle. Based on the data provided here, are the rider's knees mostly ahead or behind the pedal spindle? This rider is biased towards the rear. So by moving the saddle forward, we would expect the numbers to increase, becoming less negative in value. The range is broad, so the fitter's goal is to aim for the middle. A result of -20 millimeters is objectively the target. Subjectively, we need to make sure that the rider feels good about the saddle position, which is one reason why the range is so broad. It takes into account riders' preferences to be a little forward or a little back. In this example, we had less than 10 millimeters difference left to right. Consider differences less than 15 millimeters to be relatively symmetrical. When a rider shows a difference greater than 15 millimeters, the fitter should first consider what is causing the significant asymmetry by reviewing the pre-fit assessment. Then proceed by splitting the difference and seeing what feels best to the rider. So in this last line of data, the fitter could try moving the saddle forward 5 millimeters and see if the left knee comes into the range. Before making fore and aft saddle adjustments, we first need to show the system where the pedal is. Step 1. Start from a static stop and the rider pedals up to 70 RPM. Step 2. Position the rider's foot on the pedal block. Explain the toe point process, and then return the foot to the starting position. Finally, ask the rider to toe point once the system is ready. Once the pedal spindle is found, adjust the saddle to get the rider's knee centered in the range, moving the saddle aft for a more negative value, or forward towards a less negative value. When riding a road bike, the handlebars need to offer structural support for the upper body. Bar width should place the hands just to the outside of the shoulders. Have the same shape handlebar in the fit area in multiple widths with a loose pair of shifters. This way the fitter can actually show the rider what the proper width feels like. Here we see a rider with their bars too wide. Next we see what the rider looks like with the bars too narrow. Now we have the rider on the right width bar and she is properly supported from the shoulders down to the hands. The rider's flexibility, range of motion, torso and arm length will determine where the handlebars need to be positioned. The fitter's job is to guide the rider's handlebars into the position that best supports the upper body. Shoulder angle to wrist is the best guide for determining reach. Back angle is the best guide for setting the rider's bar height. Use the pre-fit assessment to guide how much drop the rider will need to the handlebars. Looking at the numbers here, this rider appears to be reaching a little too far because the values are more open at the shoulder than 90 degrees. And possibly a little too low. To reduce the reach, the fitter shortens the stem and the rider's shoulder angle closes a few degrees. Notice that also increased the back angle in a positive way. But how does the fitter know if that bar height and back angle is good for this rider? Go back to the physical assessment. Use the forward flexion assessment as a guide to determine a target for back angle. More flexible riders will trend towards lower back angles, while less flexible riders will need a more open back angle. Let's look at the rider's data again, this time assuming that his forward flexion was moderate. The fitter will want to try raising the bar height to continue opening the back angle. Once the drop is decreased by adding spacers or increasing the stem angle, the back angle opens up more towards 45 degrees. Also notice that the shoulder angle has decreased too, since raising the bars also brought them slightly closer to the rider. The fitter will guide the rider to rotate the bars with their hands in the drops until they find a comfortable position, ideally with a straight, neutral wrist, and where they can reach the brake levers. Once the bar rotation is set, the fitter will position the hood so that the rider has a neutral wrist again, like he is shaking hands with the shifter. Starting with the flat part of the hood's level is just that, a starting point. Often the rider's wrist will be straightest with some degree of upward adjustment. If the hoods are moved up, be sure to double check the rider's reach to the brake levers back in the drops. Nearly all modern shifters have some sort of reach adjustment. Use it so riders can confidently reach their brakes. Adjustments to bar rotation and lever position can be reflected in the elbow angle data. If a rider does not have a neutral wrist, they will often lock out their arms too. As the fitter makes adjustment to the bar and shifters, the goal will be to keep the elbows relaxed, usually less than 160 degrees. Values greater than 160 degrees are usually an indication that the elbow is too straight. Fitter begins by loosening the faceplate, and then instructs the rider to angle the drops into a comfortable position. The fitter can offer some advice here. Once the rider finds a good position, the fitter tightens the faceplate and then asks the rider if she can reach the brake levers. Finally, make an adjustment to the brake lever to bring it in closer if the rider needs a shorter reach. Next, the fitter will assess the rider's wrist position in the hoods. Take note if there is a bend or crease in the rider's wrist. Ask the rider if and where there is pressure on their hands. Adjust one brake hood as needed so the rider can compare. Then adjust the other hood up to match and ask the rider if they feel better and are even. The hip angle measurement on the bike is compared directly to the physical assessment. The rider's most closed hip angle must be no more than what was measured on the assessment table. For example, if the rider measured 115 degrees on the right and 120 degrees on the left, the fitter will measure the right hip on the bike, looking for a value less than 115 degrees. Begin by looking at the physical assessment data. Determine which hip should be measured by selecting the lower value between the two. The fitter asks the rider to pedal a hard effort while holding the drops. Stop the rider at the top of the pedal stroke. Notice the knee slightly rising to the highest point. Fitter aligns the goniometer along the femur through the center of the hip and knee with the other arm matching the sacrum. Fitter takes the measurement and checks the results. Thanks for learning about the first 8 steps of the retool fit process for road bikes. Now your rider's saddle and handlebars are right where they need to be. The next module is going to take us into the pedaling mechanics for our riders, moving through the final steps to make sure everything is perfect about their bike fit.